Hi, my name is Axel and I'm a specialist in neurodiversity and various learning difficulties using the Davis method. And this is a little video about the line of 10. You may recognize it as number bonds, and it shows how I use the concrete hands-on learning in Davis, the plasticine, to eliminate any confusion in number bonds. And there is a lot more to the Davis math mastery procedures, but this is just one simple aspect of that. Okay, this is the line of 10, and I treat it very much like we treat the alphabet with literacy. It's simply, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are looking for confusion triggering in the amount of balls. And of course, one of the key things here is what I call a boundary, because a boundary is a key idea in counting. We could have a boundary by saying, changing the condition of the balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there I was changing the condition of the balls. The counted ones are the ones that have been touched, and the uncounted ones are the ones that have not been touched. That's one way of counting, of creating a boundary, changing the condition. I could be changing the place when I'm counting, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see how the concept of order is here in creating a boundary. Now it's the place. So condition, place, and position. Now balls don't really have a position, but if I was counting lines, for example, 1, 2, 3. I'm not going to do more than 3 because it'll just take a long time. So I could be 1, 2, 3. Now I'm changing the position of the lines. So the ones that have been turned are the ones that have been counted. So I'm creating a boundary between the turned ones and the unturned ones. I've changed the position. So we create boundary either by changing a place or position or condition. So let's come back to the line of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if they're all visible. Yeah, I think they are. And I like having a divider halfway through in the middle, which is a bit like our fingers, 5 and 5. And we are now treating this very much like we do with the alphabet. We could call this, what do they call it, number bonds. I just call it line of 10. And we need to master the line of 10 until there's no confusion. So we start with the line, the boundary. This is the boundary. We start with it here, and there's nothing on this side of the boundary, and 10 on this side of the boundary. And then I move it. 1 and 9 makes 10. 2 and 8 make 10. 3 and 7 make 10. 4 and 6 make 10. 5 and 5 make 10. 6 and 4 make 10. 7 and 3 make 10. 8 and 2 make 10. 9 and 1 make 10. And of course, 10 and 0 make 10. And then we go backwards, just like with the alphabet. 10 and 0 make 10. And we always start on the same side, naming the amount on the same side. So we're kind of doing it backwards now. So we can actually recognize the large amount by just looking at the smallest amount. that gives us real fluidity in navigating the line of 10 and eventually the grid of 10 times 10. Because just like we can see that this is 1 and this is 9, in the grid of 10 we can see there's 10 and then the rest is 90 because there are 9 lines of 10. Okay, so 9 and 1, 8 and 2, 7 and 3, 6 and 4, 5 and 5, 4 and 6, 3 and 7. There was a little hesitation, you may have noticed. I lost my focus. And that's what we're looking for, just like in the alphabet. 2 and 8, 1 and 9. Again, little hesitation. I lost my focus, started thinking about something else. 0 and 10. So that's the line of 10. We go up and down and up and down, just like with the alphabet, until it's fluent. No hesitation, no mistakes. Okay? And if there are mistakes and hesitation, then we address that and allow the person to really focus and take in the mental picture here and store the mental picture that we have. Now, the line of 5 is when we remove these. We do exactly the same with the line of 5. There's 0 and 5 make 5. 1 and 4 makes 5. 2 and 3 makes 5. 3 and 2 makes 5. 4 and 1 makes 5. And of course 5 and 0 makes 5. And we go backwards. 4 and 1 makes 5. 3 and 2 makes 5. 2 and 3 makes 5. 1 and 4 makes 5. And 0 and 5 makes 5. And of course, here they are likely to discover that 1 and 4 and 4 and 1 is a mirror image, just like with the line of 10. And of course, 3 and 2 and 2 and 3 is a mirror image. So there are only like 3 combinations, 5 and 0, 4 and 1, 2 and 3, that actually need to be remembered. But they need to be recognized as well in either combination. So this is the line of 5. I'm going to come back with the 10 balls and we're going to do the line of 5 plus. And now we are looking at these 5 plus something. So we say 5 plus 0 is 5. 5 plus 1 is 6. 5 plus 2 is 7. And of course, when we're doing this way, your client will start to recognize there's the 7, 5 and 2, but there's also the 3 there, which ties into the line of 10, 3 and 7. So 5 and 2 make 7. 5 and 3 makes 8. 5 and 4 makes 9. And 5 and 5 makes 10. And we go backwards again. 5 and 4 makes 9. 5 and 3 makes 8. 5 and 2 makes 7. 5 and 1 makes 6. And 5 and 0 is 5. By doing this before we do the grid, and possibly even before we do Richard's exercise of adding and subtracting, it really allows more fluency. And especially when we recognize, for example, that 13 is 10 and 3, and then we're taking away 5 from 13, then we know we take away the 3, and remember the 5 is 3 and 2, then we know we need to take another 2. We end up here, and it becomes almost intuitive. And then again, we recognize it in the line of 10, 2 and 8, and we know that 13 minus 5 is 8. And we start navigating, crossing the line of the 10 barrier can become a problem. That can be a trigger. But by having the line of 5 and the line of 5 plus allows a fluent kind of navigation past the 10 barrier. I hope this was helpful. and I'm going to send that along or store it maybe on YouTube and send the link.